Hello students, I had started abstract algebra in the last video, but today I am going to start numerical analysis on demand of many students. In this connection, I am going to start first chapter, the solution of algebraic equations. We know many methods of solving algebraic equations. We had been reading and teaching many methods from very beginning, but in numerical analysis, the solution of algebraic equations are started with the method of bisection formula. Bisection method, this is also called as Bolzano method of solution of algebraic equations. Let fx equal to 0 be an algebraic equation if the function fx is continuous between two real numbers a and b and fa and fb are of opposite signs, then there exists at least one root of fx equal to 0 between a and b. Let fa be negative and fb be positive so that the approximate value of the root between a and b is x0 equal to a plus b by 2. If fx0 equal to 0, then x0 is the correct root of the equation fx equal to 0. If fx0 is not equal to 0, then the root lies between either a and a plus b by 2 or a plus b by 2 and b. That is, the root lies between the interval a plus b by 2 or a plus b by 2 b. If fx0 is positive and fa is negative, then the root lies between a and a plus b by 2. If fx0 is negative and fb is positive, then the root lies between a plus b by 2 and b. Thus, if fa into fx0 is less than 0, then the root lies between x equal to a and x equal to x0, that is x equal to a plus b by 2. But if fx0 into fb is less than 0, that is negative, then the root lies between a plus b by 2 and b. Suppose fa into fx0 is less than 0, that is fa into fx0 is negative, that is, the root lies between a and a plus b by 2. Now, again we bisect the interval a plus b by 2 and repeat the process. Let x1 equal to a plus b by 2 by 2. If fa and fx1 are of opposite signs, then the root lies between a and x1. On the other hand, if fx0 and fb are of opposite signs, then the root lies between x1 equal to a plus b by 2 and b. Suppose the root lies between x1 and b, then we again bisect the interval x1, b and repeat the process. Thus, we go on bisecting the interval and repeating the process until the root is obtained to desired accuracy. Or we can say that in the process of bisecting the intervals, if two approximate values are about equal, then that value may be taken as the root of the equation fx equal to 0. Convergence of bisection method. We have discussed the method of bisection or Bolzano method. Now we want to see the convergence of bisection method. The sequence action of successive approximation of a root x equal to alpha of the equation fx equal to 0 is said to converge to x equal to alpha with order q greater than equal to 1 if mod xn plus 1 minus alpha is less than equal to c into mod xn minus alpha into q, where n is greater than equal to 0, that is, n is positive integer, where c is some constant greater than 0. When q equal to 1 and c lies between 0 and 1, then the convergence is said to be of first order or linear, and constant c is called the rate of linear convergence. The convergence is rapid or slow according as c is near to 0 or 1. This means the convergence is rapid when c is near to 0. The convergence is rapid means we can obtain the root up to desired degree of accuracy in some steps, and when C is near to 1, the rate is slow, means we have to calculate many steps, about 6, 7, 8 or 9, 10 steps to get the result up to required accuracy. In bisection method, the sequence action of successive approximation converges necessarily to the root of the equation fx equal to 0, but the convergence is very slow. This is about the bisection method or Bolzano method of solving the algebraic equation. Now we take an example, that is, we take a problem for better understanding of the steps of the method. The problem I have taken is find a real root of the equation x cube minus x minus 1 equal to 0 by bisection method. For solution, let us consider fx equal to x cube minus x minus 1 equal to 0. In theory of equation, we had read that if there is real positive root equal to the number of changes of signs in fx. Here in fx there is only one change of sign, so this equation fx equal to 0 has one positive root. Again, f minus x has two changes of sign. That means the equation has two negative roots or complex roots. Here it is clear that at least one root is real. We check here f0 equal to minus 1, which is less than 0. f1 equal to minus 1, which is less than 0, that is negative. f2 equal to 5, which is positive. Means f1 and f2 are of opposite signs, and so there is at least one real root between 1 and 2. First approximation will be x1 equal to 1 plus 2 by 2, that is 1.5. Since fx1 equal to f1.5 equal to 1.5 whole cube minus 1.5 minus 1, after simplification it becomes 0.875, which is positive. We have said earlier that f1 is negative and here f1.5 is positive, and therefore the root lies between 1 and 1.5. Thus we see that the real root, which was in the interval 1 and 2, 1, 2, now the interval becomes shorter, that is 1, 1.5. The second approximation, x2 equal to 1 plus 1.5 by 2, that is 2.5 by 2, that is 1.25. Now fx2 equal to f1.25 equal to 1.25 whole cube minus 1.25 minus 1. On simplification, it becomes minus 0.29685, which is negative less than 0, and therefore the root lies between 1.25 and 1.5. Because f of 1.5 was positive and f1 was negative, and therefore the root lies between here 1.1 and 1.5. After second approximation, the root lies between 1.25 and 1.5. The third approximation, x3 equal to 1.25 plus 1.5 by 2, which on simplification becomes 1.375. Now fx3 equal to f 1.375 equal to 1.375 whole cube minus 1.375 minus 1, which after some simplification becomes 0.2246, which is positive, and therefore the root lies between 1.25 and 1.375. The fourth approximation, x4, will be 1.25 plus 1.375 by 2, that is equal to 2.625 by 2, that is equal to 1.3125. Again, f 1.3125 equal to 1.3125 whole cube minus 1.3125 minus 1, which becomes minus 0.0515 on simplification, which is negative, that is less than 0. And therefore, the root lies between 1.3125 and 1.375. Now, the fifth approximation x5 will be 1.3125 plus 1.375 by 2, which is equal to 2.6875 by 2, which is equal to 1.34375. This is fifth approximation. Now we find the value of function at this point. x5 equal to 1.34375. That is f x5 equal to f 1.34375 equal to 1.34375 whole cube minus 1.34375 minus 1 equal to 0.0826 on simplification, which is positive, that is greater than 0. And therefore, the root lies between 1.3125 and 1.34375. Now we compute sixth approximation. The sixth approximation x6 will be 1.3125 plus 1.34375 by 2 equal to 1.32815 on simplification. Now the value of function at x6, that is f x6, which is equal to f 1.32815 equal to 1.32815 whole cube minus 1.32815 minus 1 equal to 0.01456, which is greater than 0, that is positive. The value of function at 1.3125 was negative and the value of function at x equal to 1.32815 is positive, and therefore the root lies between 1.3125 and 1.32815. Now we calculate the seventh approximation. The seventh approximation x7 will be equal to 1.3125 plus 1.32815 by 2, which is equal to 1.3203125. In this way, we can obtain the root to the desired degree of accuracy. Earlier, we had seen that f1 was negative and f2 was positive, and so we had taken that the real root lies between 1 and 2. If we had taken f at 1.1, 1.2, 1.3, 1.4, 1.5 and so on, and search the value of function where it becomes positive, then the interval would have shortened, and then we can get the value of root up to desired degree of accuracy very earlier. This is about the method given by Bolzano or bisection method, and thus we have discussed the method steps and given an example for solving the algebraic equation by bisection. Hello students, we shall discuss more topics and important topics, important theorems and problems of degree part 3rd and other courses. So please subscribe my channel. Thank you.